If we just look at this example here, this is an example from the demo app where we've performed a convolution operation on this input image of a 7 from the MNIST dataset, and we have this resulting output. So we know that the image dimensions have reduced from size 28 by 28 in the input to now 26 by 26 in the output. And by looking at this, it really doesn't seem to be that big of a deal because we still have our 7 clearly showing in the output space, and we didn't really lose much information about the input image. And that's fine for this example because actually we don't have much useful information in these MNIST images around the edges of the input. So that loss of pixels around the edges here is not very concerning because we don't really have any data around the edges of the input that we care about preserving. But we could imagine that this would be a concern if we did have data around the edges that we cared about preserving from our input. Additionally, with this example, we only convolved our input with a single filter. But what if we convolve this input by multiple filters through multiple layers in the network and continue to do so as the network gets deeper and deeper? Well, as this input is repeatedly convolved layer after layer, the resulting output is going to become smaller and smaller. This can potentially become a problem, especially for images that have smaller dimensions to begin with.